All right, so we have been talking about solving equations, just normal equations, not really anything special or fancy about them. And now we're going to move into solving absolute value equations. So we're looking at equations that involve absolute value. So we have a couple vocabulary words to go over first. The first one is absolute value itself. So when we talk about absolute value, a lot of times what I hear is that the absolute value of something is just the opposite of it, right? So if I have the absolute value of -2, it's just 2. So what I do is I take the absolute value of something is just making a negative number a positive number. And while that's partially true, that's not the whole picture. So when I'm talking about absolute value, I'm talking about the distance a number is from 0. So if I'm talking about the absolute value of 6, let's say, the absolute value of 6 is 6 because it's just 6 spaces away from 0. Or if I have the absolute value of -13, maybe. Absolute value of -13, that's just going to give me a +13 because it's 13 spaces away from 0. Okay, our next definition is extraneous solutions. Okay, there's a word in extraneous solutions that can help us figure out what this means. So my first 5 letters of extraneous are extra. Okay, when I'm talking about extraneous solutions, I'm talking about extra solutions. So when we solve absolute value problems, particularly absolute value equations, I'm always going to be left with more than one answer. Generally, there'll be 2 solutions to my equations. Now, sometimes one of those solutions is inaccurate. It doesn't work. So when I plug that number back into my original equation, it does not give me the right answer. So an extraneous solution is an extra solution extra solution that does not work. When substituting. Okay, so when I plug my answer back into my equation, it does not work. It's an extraneous solution, it's extra, it doesn't work. All right, I've got some properties of absolute values. First one is pretty straightforward. The absolute value of a number or an expression is always greater than or equal to 0. So absolute value always greater than or equal to 0. Conversely, what this also means is that absolute value is never negative. Absolute value is never negative. Ever. Ever, 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 ever. Next one is the absolute value of -a is a. So all this is saying is that the absolute value of a negative number, negative value, I'm going to say a negative expression. Well, negative expression is its opposite. Okay, that says the absolute value of a negative expression is its opposite. And we know that's true. If I say the absolute value of -2, the opposite of -2 is +2. Right, so the absolute value of a negative expression is its opposite. This next one then, these next two really, there we go. These next two are essentially the same expression or the same rule property, just with multiplication and division. So what these say is that the absolute value of a product of two numbers can be broken up between the absolute value of the first one times the absolute value of the second one. Same thing with division. The absolute value of A over B is the same as, you can't really see it very well here, but it's the same as the absolute value of A on its own divided by the absolute value of B on its own. So, the product slash quotient of the absolute value, I don't like how this is written. Let's say it like this. The absolute value of a product or quotient is equal to the absolute value of the first number times or divided by the second, the absolute value of the second. Okay, it's the same for both. The absolute value of a product or quotient is equal to the absolute value of the first number times or divided by the absolute value of the second number. I can break them apart. Okay, some examples. So I had said that absolute value often has two different solutions. So if I'm looking at the absolute value of x equals 7, I have two possible solutions for x. X can equal -7, right? The absolute value of -7 is 7. Or x can equal 7. That's a 7. All right. Another way that I could write this is x equals plus or minus 7. Okay, this tells me that x can equal +7 or x can equal -7. Either option works, but x equals plus or minus 7. The next one then, the absolute value of x equals -4. I said the absolute value of something can never be negative, right? Never, never, never be negative. So this is an example of a no solution. We talked about no solutions with our last in 1.3. And so this is our example of no solution when it comes to absolute value. The absolute value of x equals -4 is a no solution. Why? Because absolute value can never be negative. Okay, Okay, and I have a little reminder of that down here. So if your equation on one side, your absolute value, equals a negative number, there will be no solution. All right, some examples. These are kind of tricky, so we're going to walk through probably all of these together. When I'm dealing with absolute value equations, I need to account for the fact that what is inside the absolute value can either be a positive number or a negative number, right? In absolute values, I can take the absolute value of a positive number or a negative number, it doesn't matter. So I need to write equations that take into account both of those scenarios. So the way that I do that is like this. I've got the absolute value of 2x plus 4 equals 6. So I'm going to set up my two equations this way. 2x plus 4 equals 6. Simple, easy peasy. Okay. The way that I'm going to set up the second one is I'm going to keep this first value. I'm going to keep my 2x plus 4, but I need to negate the right-hand side of my equation. So my two equations are 2x plus 4 equals 6, or 2x plus 4 equals negative 6. I keep the first expression. I negate my other expression. Make it negative. Now I just solve these like normal, right? So I'm going to subtract 4 from both sides. I'm left with 2x equals 2. Divide by 2. X equals 1 for the first equation. Second equation, same deal. I'm going to subtract 4 from both sides. I'm left with 2x equals negative 10. Divide both sides by 2. I'm left with x equals negative 5. Here is what I'm going to say to you about these equations now, or about your solutions. This is still, oops, this is still an or. Here's what I'm going to say. You should now get into the practice all the time of checking your answers, okay? With absolute value problems, like I said, sometimes there's going to be extraneous solutions. Sometimes there will be solutions that aren't actually true. They don't actually work. So I need to make sure that both of my solutions work in my original equation. So I need to plug them back in. So I've got x equals negative 5. So if I plug negative 5 back in here, take negative 5, put it in here. Whoops, right? I've got negative 5 times 2, which is negative 10. Negative 10 plus 4 is a negative 6. Absolute value of negative 6 equals 6. Do the same thing with my 1. 2 times 1 is 2, plus 4 is 6. The absolute value of 6 is 6. These both check out. Okay, my next one. Absolute value of 4x minus 6 equals negative 4. This one should be pretty obvious to you right off the get-go. I have the absolute value of something equals a negative number. Can it equal a negative number? No, it cannot. This one is just no solution. Absolute value cannot be negative. All right, these next two require some more steps. So, you have to think of absolute value as something on its own. I can't combine things on the outside with absolute value. So in this one, the absolute value of 3x minus 9 minus 10 equals 35. It would be tempting to combine like terms, right? It would be tempting to take this negative 9 and this 10 and put them together. I can't do that. I can't do that. My negative 9 is on the inside of my absolute value signs, brackets, and my 10 is on the outside of my absolute value brackets. So I can't just combine those. So my first step then is going to be to add 10 to both sides so that I can get my absolute value by itself. So then I'm just left with the absolute value of 3x minus 9 equals 35 plus 10 is 45. Now I can rewrite this like I did my last ones. So I can have 3x minus 9 equals 45, or 3x minus 9 equals negative 45. I'm going to add 9 to both sides. Leaves me with 3x equals 54. We'll divide both sides by 3. Leaves me with x equals 18. I'm going to do the same thing over here. Add 9 to both sides. I'm left with 3x equals negative 36. Divide both sides by 3. X equals negative 12. Can plug these back in, okay? Negative 12 times 3 gives me a negative 36. Negative 36 minus 9 gives me a negative 45. Absolute value of negative 45 is positive 45. I can also plug this back into my original equation, right? So if I were to do that, I've got negative 12 times 3, negative 36. Negative 36 minus 9, negative 45. Absolute value of negative 45 is a positive 45. Minus 10 gives me 35. My 18 checks out too. Okay, so these are both good. This last one here then, you may be tempted to look at it and say, this is a no solution, Mrs. Olson. And I would tell you that you are wrong. Why would I tell you that you're wrong? Because I have an extra step. A lot of people would look at this and say, well, I have it equal to a negative 5. Absolute value can't be negative. It's a no solution. It is not a no solution, and here's why. I can rearrange this equation by adding 14 to both sides. Okay? When I add 14 to both sides, that leaves me with the absolute value of 3x minus 9 equals 9. Will this have a solution? Yes, it will. Now I just need to set up my two equations, right? I've got 3x minus 9 equals 9, or 3x minus 9 equals negative 9. Now I just solve. Add 9 to both sides. 3x equals 18. Divide both sides by 3. X equals 6. Same thing over here. Add 9 to both sides. I'm left with 3x equals 0. If I divide both sides by 3, I just know x is going to equal 0. It has to. I can plug these back into check, right? If x equals 0, 3 times 0 is 0. 0 minus 9 is a negative 9. Absolute value of negative 9 is a positive 9. Positive 9 minus 14 gives me a negative 5. They both check out. All right, we're going to move into some more complicated problems here. This rule looks kind of confusing at first, but I promise you it's not that scary. If ax plus b, the absolute value of ax plus b, equals the absolute value of cx plus d, then ax plus b equals cx plus d, or ax plus b equals negative cx plus d. So, what this is saying, it's the same thing that we've been doing, okay? If I have an equation like this, I keep this the same. Oops. This, well, this, there we go, stays the same. Stays the same. This, we make negative. Here's the easiest way to think about this. If I want to make something a negative number, what do I need to multiply it by? If I have the number 3 and I want to make it negative, what can I multiply it by to make it negative? A negative 1, right? So the easiest way that I can think of to explain this is that to make this negative, I need to multiply this whole thing by negative 1. So here are what my two equations will look like. I will have 4x minus 6 equals 7x plus 8, or I'm going to keep this the same, 4x minus 6. I need to make this next one negative. So to make it negative, I need to multiply the whole thing by negative 1. So I've got negative 7x minus 8. I'm making the whole thing negative. Now I can just solve these. I'm going to add 6 to both sides. 4x equals 7x plus 14. I'm going to subtract 7x from both sides. Left with negative 3x equals 14. Okay, I'm going to pause you here. Here's what I'm going to tell you about how I want you to deal with situations like this from here on out. In the past, what you would probably do at this point is plug this into your calculator and give me a decimal. Here's what this would look like, right? If I pull up my calculator, whoops, that's my calendar, don't want that. If I pull out my calculator, and I know that I needed to divide both sides by 3. So I've got negative 14 divided by 3. When I do that, it gives me negative 4.66666666666 repeating forever and ever and ever and ever and ever. I don't want to do that, okay? This is not helpful to me. If I were to keep going using this value, all of these decimal points are not helpful to me. So what you're going to do from here on out is you're going to leave it as a fraction. So I know that I need to divide both sides by negative 3. That means then that my x is going to equal negative 14 oh come on, over 3. See if it'll work over here. Negative, nope. Negative 4, no. Let's try this again. Last time, third time's, fifth time's a charm, whatever. X equals, there we go, negative 14 over 3. Okay, I am going to leave it like this. I'm not going to do anything to it. This is my answer, negative 14 over 3. Leave it like that. All right, do the same thing over here. Add 6 to both sides. I'm left with 4x equals 7x plus 4, nope, minus 2. Negative 7x. Negative 7x minus 2. Okay, to get rid of this, I need to add 7x to both sides. 11x equals negative 2. Using the same thing that I just told you about this answer over here, I will divide both sides by 11, but that's going to leave me with x equals negative 2 over 11. normally we would go back and check our answers. These are obviously not fun ones to check your answers on because of the fractions. So we'll just believe that they're true. They are true. I checked it. They both equal 6 2/3. Okay? All right. We're going to move on to some practice then, down here. This one might throw you off a little bit because you see the negative 3d. Okay? This is not going to change. Remember, I keep the first one and I negate the second one. So I am just going to rewrite this because I already know the absolute value of negative 15 is just a positive 15. It's not a plus or minus, it's just positive 15. So I'm just going to think of it like that. Now I've got negative 3d, because this stays the same, equals 15, or negative 3d equals negative 15. This is simple. It's a one-step problem, right? I'm just going to divide both sides by negative 3. So this leaves me with d equals negative 5. Okay, do the same thing over here. Divide by negative 3. D equals positive 5. Negative divided by a negative is a positive. So in this case, d can equal plus or minus 5. This next one, the absolute value of q minus 8 equals negative 22. You should be able to answer right away. Absolute value is never negative, right? This is a no solution. All right. Next one is going to look like this. Here we go. 2c plus 8 equals 10c, or 2c plus 8 equals negative 10c. I am not going to touch my constants. I made that mistake earlier today because it doesn't matter, right? I can just leave it where it is. So I'm just going to subtract 2c from both sides. I'm left with 8 equals 8c over here, which tells me that c is 1 on this side. I'm going to subtract 2c over here. I'm left with 8 equals negative 12c. I'm going to divide both sides by negative 12. But I need to simplify this. 8 over negative 12 is not in simplest form. So how am I going to reduce this? Well, I can see by looking at this. 4 goes into 8. 4 also goes into negative 12. 4 goes into 8 2 times. 4 goes into negative 12, it'll be negative 3, right? So c is negative 2/3. Last one, we've got 3x minus 4 equals 3x minus 5, or 3x minus 4 equals negative 3x plus 5. Okay, this one's an interesting case, right? So if I look at this first one, I'm going to solve by adding 4 to both sides, right? So I've got 3x equals 3x minus 1. Is there a solution to 3x equals 3x minus 1? No, there is not. This is a no solution. This way does not work. This is an example of an extraneous solution, right? This side does not work. But I can work with this next side, right? So I'm going to add 4 to both sides. 3x equals negative 3x plus 9, right? I can add 3x to both sides. I'm left with 6x equals 9. Divide both sides by 6. I need to reduce, right? X equals, 3 goes into both of those. 3 goes into 9 3 times. 3 goes into 6 2 times. I'm left with x equals 3 halves. So my only solution for this problem is x equals 3 halves. I don't have two solutions this time around. Okay, last one. So, this is how this one's going to look. We can set these up. We know how to do this now. 3n plus 18 equals 6n. Or 3n plus 18 equals negative 6n. I'm going to subtract 3n from both sides. I've got 18. Oops, come on. 18 equals 3n. And then I'm left with n equals 6. Okay. It's a little messy, but you get the idea. Do the same thing over here. I'm going to subtract 3n from both sides. I've got 18 equals negative 9n. Divide both sides by negative 9. I've got n equals negative 2. All right. We would look at this and say, well, I got two answers. Neither one of them was no solution, so this is it, right? I'm done. However, we need to plug our numbers back in. So let's start with 6. 6 times 3 is 18, right? 18 plus 18 is 36. The absolute value of 36 is 36. 6 times 6 is 36. 6 checks out. 6 is good. Negative 2. Negative 2 times 3 is negative 6. Negative 6 plus 18 is 12. The absolute value of 12 is a positive 12, right? 6 times negative 2 is a negative 12. So I've got the absolute value of 12 equals negative 12. Is that true? The answer is no. No, that is not true. Right? This is not a solution. N equals negative 2 is not a solution to my problem. The only solution that I have for this equation is n equals 6. That's the only one that works. And that is all for 1.4.